So let's draw the rock cycle, sketch it out. And we're going to start by showing how the igneous rocks form. So all igneous rocks form the same way as a result of magma, which is liquid rock, basically, rock that was heated up to the melting point so it's liquid. And that magma cools off. Cools and minerals start crystallizing out of the magma. So we're going to write along this arrow here. Cooling and crystallization. And that forms igneous rock. So that's pretty simple, right? Igneous rocks just form from cooling and crystallization of magma. So I'll show a picture of some igneous rocks. So this is a picture of Yosemite National Park and the Half Dome rock formation and this big broad Yosemite Valley here. And all this rock that you see around the valley is igneous rock, and that formed long ago from magmas that were down in the Earth's crust that cooled and crystallized completely beneath the surface. And later all the rocks up above were eroded away, and the igneous rocks are exposed at the surface today. At the very end of the semester we'll talk about glaciers and glacial erosion, and this Yosemite Valley was actually carved out through glacial erosion. So if we looked closely at the igneous rock here, we'd see that the rock's made up of crystals. And we'll look at the igneous rocks in more detail in the igneous rock chapter, but one of the distinguishing characteristics, or probably the distinguishing characteristic you could say, of the igneous rocks is that when you look closely at the rock shows this interlocking crystalline texture. That's because as the magma cools, the crystals grow until they're all pretty much touching each other. They intergrow and you get this interlocking crystalline texture, I call it. So we'll show that when we go over the igneous rocks in the upcoming module. So let's go back to the rock cycle diagram now, and we'll show how the sedimentary rocks form. Sedimentary rocks are made of sediment, or what most people would call dirt. But so what we're going to do first is show where the sediment comes from. And that comes from pre-existing rock. Could be any kind of rock, but we have the igneous rock here, so we'll say the igneous rock is the one we're going to start with. And that igneous rock has to be uplifted to the surface, so uplift has to happen. That exposes the pre-existing solid rock at the surface of the earth, where weathering can take place. Weathering refers to different processes that act to break the solid rock down into smaller pieces, or there are chemical weathering processes that can do things like dissolve minerals in the rock, but got to break the rock down. And then we get smaller pieces that can be eroded away or moved from where the rocks are at the surface of the earth. So we call that erosion, removing the weathered materials, moving them somewhere. And they might be transported for some distance, maybe in a river, for example. Eventually they're going to stop moving, and when the sediments stop moving, we say they're deposited, or we call that deposition. Okay, so the sediments are these deposits of material that were derived from the breakdown of some kind of pre-existing rock that it was exposed at the surface of the earth. So you might think of things like a sand bar in a river, or sand on a beach, or mud or something like that. And of course that's not a rock, that's just loose sediment or dirt, you could call it. But in order to make a sedimentary rock, that has to be hardened into rock. So there's a fancy term for that. We can call it lithification. Okay, lith, remember, means rock, so we're going to turn that sediment into a solid sedimentary rock. We're going to lithify it. And then we have our sedimentary rock. Now the lithification, that happens beneath the surface of the earth when the sediments have been buried under a whole lot more sediment, actually. And we'll talk about all these different processes, the weathering, the places where sediment accumulates, and the lithification processes. We'll talk about that in the sedimentary rock module. We'll have weathering and sedimentary rock module in a week or so. So let's shift now. We'll show you a picture of some sedimentary rocks. A good place to go to look at a lot of sedimentary rocks is the Grand Canyon. So we're up on the rim of the Grand Canyon here, looking down into the canyon, and you can see all these layers of rock cropping out on the canyon walls and up here in a closer view. And that's really the main distinguishing characteristic of the sedimentary rocks, is their layering. The sedimentary rocks are layered because the sediments get laid down or deposited layer upon layer in different places on the surface of the earth. So let's go back to the rock cycle diagram and we'll show how the metamorphic rocks form. Alright, so the metamorphic rocks, it's kind of a simple story to show how they form. Again, you have to start with some pre-existing solid rock, and since we have the sedimentary rock here, we'll start with that. Now, metamorphic rocks form as a result of a pre-existing rock being subjected to higher temperatures or higher pressures, or oftentimes it's both increases in temperature and pressure. So let's write high temperature, or we could say increased temperature and or pressure. And it has to be, hot enough or high enough pressure that you get some changes in the characteristics of the original rock, and then you have a metamorphic rock. All right, so that's our third main rock type, metamorphic rock. If the temperatures get too high, the rocks start to melt, and eventually you start producing magma instead of a metamorphic rock. So if we keep increasing temperature, we can melt the rock, produce magma. So this heating, the high pressure, that goes on beneath the surface of the earth, down in the crust. So these metamorphic rocks are all going to form down within the crust. And let's see if we can find a picture to show of the metamorphic rocks. The metamorphic rock in this picture is from the hill country region of central Texas, and it's metamorphic rock that's called gneiss, that kind of metamorphic rock. And it has this characteristic striped or banded look to it, with dark colored and light colored, or in this case kind of pink colored mineral bands. So gneiss is a metamorphic rock that forms under really high temperatures and pressures. And the temperatures got so hot when this rock was being metamorphosed that you can see the rock was starting to melt, and the mineral bands got all crinkled up due to the high temperatures and the pressure that the rock was under down in the crust. Metamorphic rock is a crystalline rock type like the igneous rocks. In other words, if you look really closely at the rock, you see it's made of mineral crystals. So sometimes it can be difficult to distinguish between igneous rocks and metamorphic rocks, but not in the case of a rock like gneiss, because in the gneiss you see this banding, and you don't see that in the igneous rocks to the way it's developed in the metamorphic gneiss. So when we go over the igneous rocks, we'll show you some of the ways you can distinguish between the metamorphic rocks and the igneous rocks. There's a lot of different kinds of metamorphic rock, different kinds of igneous rock, different kinds of sedimentary rock. So we'll go over each of those in detail in the upcoming modules. Okay, so we're back looking at the rock cycle diagram, and we want to add one last thing here, and that's to show some of the other ways rocks can be transformed besides what we showed here. For example, you could take any kind of rock, like a metamorphic rock, and uplift it at the surface of the earth, and then that uplifted metamorphic rock could become the source for sediments and eventually forming a new sedimentary rock. Or you could take a pre-existing sedimentary rock down in the crust, uplift it, and the uplift is usually due to some kind of mountain building going on, uplift it at the surface, and the sedimentary rock will become the source for sediments and the formation of a new kind of sedimentary rock potentially. Or you could take an igneous rock and change the temperature and pressure conditions it had formed at and turn it into a metamorphic rock. Or you could take a pre-existing metamorphic rock and, as a result of different temperature and pressure conditions, it could form a different kind of metamorphic rock. So it's not as if to say that the rock cycle has a starting point with magma or something like that. There's no really starting point or ending point. It's just showing how the rocks are transformed from one rock type to another. And really, it's going to be the plate tectonic engine that drives these transformations. So as we go over each of the three main rock types, we want to show also how those different kinds of rocks form in different types of plate tectonic settings. So we'll look at all those ideas in the next few weeks.